Amplitude and wavelength. Amplitude. The amplitude of a wave is defined as the maximum displacement of the elements from the equilibrium position. In order to explain the amplitude, what I'm going to do, I'm going to consider a function of sine. So basically this is how the wave is oscillating, where this is my x-axis and this is my y-axis. As you can see, the medium particles are going in both the two directions, which is basically over the x-axis and below the x-axis, and these dots are basically the maximum displacement from the equilibrium position. So this displacement is basically A on both the two directions, basically over and below the x-axis, and this maximum displacement from the equilibrium position is known as amplitude. Now let's talk about the wavelength. So the wavelength of any wave is defined as the minimum distance between two consecutive crests or troughs. So in order to explain the wavelength, what I'm going to do, I'm going to consider the same type of wave. So this is my sine wave, where you can see this is the crest and these 2 points are the trough. So basically crest is the maximum displacement over the x-axis and the trough is maximum displacement below the x-axis. So if we consider the distance between two consecutive crests, or we consider the distance between two consecutive troughs, then that distance is denoted by lambda, and that distance is also known as wavelength. So basically the wavelength is denoted by lambda, and this is how we define the amplitude and wavelength of a wave.